What is water chemical potential or the solute potential or the pressure potential? Is the concept is just an extension of the classical concept what we have discussed about osmosis, diffusion, turgor pressure and so on? Is it? Yes, it is. This is Dr. Pankaj Kumar, your mentor for today's sessions. So today we will be discussing about the very concept of potentials, right? So first of all, we will talk about water potential and their components, how the potential is going to change in a soil water air system, and we also understand that how the ascent of sap is going to happen and how the plant is going to absorb the water. Okay, so first thing first, let's start discussing about the water chemical potential. Now, what is the meaning of potential? You know, potential is nothing but it is an energy. So naturally, if you talk about water chemical potential, it is also energy. So the energy that is associated with the water molecules, they together constitute a water chemical potential. You know, the moment you talk about any, for instance, taking an example of water, it consists of both cation and anions. So the sum of all energy is always zero, right? So for pure water, what we say that water chemical potential is always and always zero. Okay. Now let's discuss what are the components of water chemical potentials, right? The components are solute potential, pressure potential, matrix potential and gravity potential. So today, one by one, we will discuss about all this potential, right? Let's talk about solute potential. And in order to understand the solute potential, let's take an example. Suppose I take a beaker, right? And in this beaker, what I have taken, that a pure water. So since it is a pure water, so water chemical potential is zero. Now what I am doing, I am adding a salt. So the moment you add a salt, what will happen? Some of the water molecule is going to bind with the salt. So the energy associated with those water molecules that were earlier contributing to the water chemical potential of pure water has been withdrawn from the system. And since it is withdrawn from the system, what we can say that the potential for the solute is always going to be negative. So that is the reason why the solute potential is always and always negative in nature. Okay. So we can define solute potential in terms of the total amount of salt that is added in any pure water. So the greater the amount of salt, the lesser the amount of potential, because we know very well that solute potential is always going to be negative in value, and it is expressed by a Greek letter that is pi, right? Now let's talk about the next, what we call pressure potential. You see, the pressure potential is absolutely similar to the turgor pressure. Now what was the turgor pressure? That was the outward pressure. Okay. So if the protoplasm is going to exert outward pressure on a plasma membrane, then we call it as a turgor pressure, right? So in a flaccid cell, what we will see that the pressure potential is going to be negative. Okay. But at the same time, the pressure potential can be positive, can be negative and can be zero. So if it is the flaccid, I told you that it will be zero. But when it is going to be positive, take an example of our blood vessels. You prick it, the blood will ooze out. So oozing out of liquid, why it is happening? It is happening due to positive pressure potential. You prick any leaf, liquid will ooze out. So oozing of liquid denote the pressure potential is absolutely positive. Okay. Take an example of xylem. You prick a xylem, is it possible to get a water? No, sorry, you can't. Why? Because xylem is under tremendous suction pressure. And as a result of suction pressure, what happens? That pressure potential in those cases are absolutely negative. So xylem is a perfect example where we see that pressure potential is going to be negative, right? So let's talk about the next, what we call matrix potential. You see, the very concept of matrix potential is nothing but it is an extension of the imbibition. Now what happens in case of imbibition? The water is going to imbibe. So naturally, the energy associated with those water that is going to be imbibed is also going to be lost. Okay. So here also what we see that the potential, the value is always negative. It cannot be positive because the energy from the system is going to be withdrawn due to imbibition of the water. Okay. And matrix potential is represented by a Greek letter, what we call tau, right? Okay. You see, in all our calculation, what happens, metric potential is almost negligible in value. So for all practical purpose, we don't take into consideration. Similarly, there is a one what we call gravity potential. Now, gravity potential is the potential that a plant required to overcome the force of the gravity, right? And its value is also negligible. So that's why for all our practical purpose, we don't consider the matrix potential as well as the gravity potential. So at this particular level, we will concentrate on only two, and that is the solute potential and the pressure potential. Now let's talk about the components. Mathematically, we can show it like this. You see there, this is a water chemical potential, is a sum of solute potential, pressure potential, matrix potential and gravity potential. Since I told you that matrix and gravity potential is negligible, so for all practical purpose we can say that water potential is equal to solute potential per pressure potential. Or we can also say that pi, that we denote in case of the water chemical potential, that is equal to, or psi is equal to pi plus p, right? So that become the relation between the different potentials for all practical purposes. Now let's assume two conditions. Suppose the cell is flaccid. Now if the cell is flaccid, right now we have earlier discussed that pressure potential is going to be 0. So if I put the value of 0 in the equation right now just we have discussed, so here what we see, that water chemical potential is equal to the solute potential, right? Similarly, if the cell is going to be turgid, what will happen? That there will be no water chemical potential. And if there is a no water chemical potential, then in that case what we see, that pressure potential is equivalent to the minus solute potential. So these are the two main relations what we have to keep in your mind, right? Now let's try to understand the concept in some wider aspects, in which we will be discussing the entire things with reference to soil, plant, air system. Okay. So one basic thing what we have to understand, that water potential is highest in soil and lowest in air. That we have to understand. Secondly, water always moves from higher potential to lower potential, right? Under these two things, we will discuss this simple concept. So right now, you can see in the diagram that there is a plant showing the root, stem and the leaf. Okay. So here what we will see, that when the water is moving from soil to the air, then how the potential in terms of water chemical potential, solute potential and pressure potential is changing. I would like to have your concentration. So have a look at the very first. Just see, here S stands for soil. So what happens, that water chemical potential, if you compare with the soil and root, then in case of soil it will be more. Why? Because water flows from higher potential to the lower potential. Similarly, if you talk about the pressure, in case of root the pressure is a high. Why? Because the earth is not going to covered by any membrane, so it is an open system. As we have seen earlier that in case of beaker the pressure potential was 0, so here also we can consider it like that. So that's why for soil the pressure potential is going to be 0. Now have a look at this. In order to understand the solute potential, one thing you have to ask with yourself, and that is, which of these two is going to have a greater amount of salt? Is it soil or is it root? Of course it is root. That is why endosmosis happens. So greater the amount of salt, lesser the potential, because it is going to have a more negative value. So that is why here what we see, that soil has a greater solute potential in comparison to root. Okay. Have a look at the second case. In second case, we are going to compare the root with a xylem, because water is going to move from root to xylem. It is obvious that water chemical potential of root will be more than xylem, because water is flowing from root to xylem and water flows from higher potential to lower potential, right? What about the pressure? We know very well, xylem has a negative pressure potential due to excessive suction pressure. So pressure potential of root will be more. Now what about the solute? Again, we have to ask the same question. Given the root and xylem, which is going to have a more amount of salt? Of course the answer is salt. Of course the answer is root. If the answer is root, what does it mean? That root has a more negative value. So solute potential of xylem will be more. isn't it? So if we extend the same logic or argument to the next level, that is the xylem to the leaf, then what we see that water chemical potential of xylem will be more in comparison to leaf, since water is flowing from xylem to leaf. Pressure potential in case of leaf is more because xylem has a negative value, and in case of leaf what happened, you prick the leaf, liquid will ooze out, that means pressure potential is positive. Okay, and as far as the solute potential is concerned, again leaf has a more salt, so naturally it has a more negative value, so naturally the solute potential in case of xylem will be more. So this is how we can describe the entire soil plant air system. I hope the concept is absolutely clear at your end, right? Let's talk about that how water is going to be absorbed. Okay, we know very well absorption of water occurs through the root hair zone, and the process of absorption is osmosis. It is a passive process, no energy is involved. Now let's try to understand the entire process with a simple diagram that is in front of you. We know very well that from soil the water is entering due to osmosis. But the moment water enters, if you compare the root hair cells with the adjoining cells, what we will see? That the osmotic concentration of the adjoining cells, let it be A, will be high in comparison to root hair cell. Why? Because the water has entered. So naturally, due to difference in the osmotic potential, since root hair has a lesser potential, and cell number 1 has a more potential or more concentrated, so what will happen? Water will flow from here. Okay. Again, if you compare cell number 1 and cell number 2, so since water has entered into cell number 1, so naturally it has now got less concentration in comparison to cell number 2. So again, due to osmosis, the water will enter over here. Likewise, eventually the water enter into the xylem tissue. So this is how the absorption of water is going to occur, right? Finally, let's talk about some of the absorptive pathway. Now we can divide absorptive pathway into two groups, what we call apoplast and symplast. Now what is apoplast? Apoplast is a pathway that involves the dead material, and there is only one way, one example, and that is through the cell wall. What is symplast? That is the pathway involves the living things. So the symplastic pathway can be of two types, what we call a vacuolar pathway and pathway involving plasmodesmata. Okay, you can see in the diagram as well. So in the one, you can see that this is the pathway where transportation is going to occur to the cell wall. In second, we see that there is a plasmodesmata through which the transport is going to happen, and here it is a vacuolar transport. The question is asked that which of these contribute most as far as the absorption of water is concerned, and the answer is apoplastic pathway, that is a cell wall. So these two constitute very, very negligible. So the maximum water passes through the apoplastic pathway. So this is the only thing what we have to learn as far as the absorptive pathway is concerned. Let's come to our final thing, and that is ascent of sap. First thing first, what is sap? Sap is the nutrient plus water. Okay. So it is conducted through xylem, and different theories has been given that how the ascent of sap is going to occur against the force of gravity. So broadly, theory has been divided into two groups, what we call vital force theory and physical force theory. Now what is a vital force theory? This theory is talking about that the ascent of sap is going to occur due to living activities of the cell, right? So there are different peoples at the different point of time has given these theories, but we will not discuss about that because it is thoroughly rejected. Vital force cannot be the reason for the ascent of sap. So that's why the physical theory stands true. Even the physical theories has been divided into different types like capillarity theory, root pressure theory, and the most acceptable one, what we call the transpiration pull theory, given by Dixon and Zolli. Okay, first see what is root pressure theory. Now in case of root pressure, what happens? Due to osmotic uptake of water, the pressure is generated over the endodermal wall. because in the endodermis you see there is a Casparian stress, right? So let's try to understand by very simple figure. Have a look at this figure. So this is the endodermal wall of root. So what we see that there is a Casparian strips, right? So the water is entering over here. So water cannot enter over here. So water can enter only at the through the passage cell. So since there is a continuous flow of water, and since the Casparian strip doesn't allow the very passage of water, so what happens? It generates a pressure. So that pressure is actually called as a root pressure. Okay, but this root pressure is applicable only in case of the herbaceous plant, not in case of the bigger trees. So Netzel, the most accepted theory, stand at that that is the Dixon and Jolly theory or transpiration pull theory. Okay, so let's talk about the transpiration pull theory. So transpiration pull theory says that there is a strong cohesive and adhesive force. Okay, so the strong cohesive force exists between the water molecules, and a strong adhesive force exists between the water and xylem cells. So these two forces together form a continuous hydrostatic column. Okay, so when transpiration pull is generated, then due to this continuous water column, the water reaches from the bottom to the tip. Okay, so one thing is again I would like to make it clear that suppose some water bubbles has entered into hydrostatic column. Is the hydrostatic column is going to be broken? Answer is no. Why? Because you see, the transpiration pull generate a pressure of equivalent to 125 atmosphere, and the requirement to pull the hydrostatic column against the force of gravity is just 5 to 6 atmosphere. So you can understand the difference. So even if water column is there, so hydrostatic column is not going to be broken. So everything is actually pulled up along with the water molecule itself or air bubble itself. Okay, so this is stand as the most accepted theory, right? So that's all what we have to discuss.